Hello everyone, welcome back to JDCodebase. In this video, we are going to solve LeetCode 169 majority element, which is part of the LeetCode top interview 150 study plan. And this is a very important interview problem because it teaches us how to think smartly instead of using extra space or brute force solution. So now let's first understand the problem clearly. We are given an array called nums of size n, and our task is to find the majority element, and majority element means an element that appears more than n divided by 2 times. And one very important line is given in this problem is you may assume that the majority elements always exist in the array. So this single line changes everything, and we will use this fact in our optimal solution. So let's understand this with example. In the first example, the array is 3 to 3, and the size of the array is 3, and n by 2 is the 1 now. So here the number 3 appears 2 times, which is more than 1. So the answer is 3 here. And in the example 2 nums array, it has the 2 2 1 1 1 2 2. So the size is the 7 here, and n by 2 is 3, and the number 2 appears 4 times, which is more than 3. So the output is 2 here. Very simple logic, but the challenge is how to do it efficiently. Now let's quickly check the constant. The array size can go up to the 50,000, and the values can be very large, even negative also. So if we use sorting or extra memory blindly, it may not be the best interview solution. That's why interview accept the big of n and big of 1 space solution here. Now this is the most important part of this problem. Let's think slowly. If one element appears more than n by 2 times, that means even if we try to cancel it with all other elements, it will still survive. So the idea is very simple. Let's take one element as a candidate and increase the count when you see the same element, and decrease count when you see a different element. And when count becomes 0, pick a new candidate. In the end, the remaining candidate will be always be the majority element. So this work only because the majority element is guaranteed to be exist. So let me explain this step clearly. First, we start with the initialize with the candidates is equal to null and count is equal to 0, and loop through the array. And if count becomes 0, we set the candidate, select the current number as the new candidate. And if the current number is equal to candidate, we increase the count, and otherwise we decrease the count. And at the end, we return the candidate. And we do not even need to verify again because the problem guarantees the answer. So now let's do a try run because this is where most confusion happen. Let's say the first element is 2. Now we assign the candidate is equal to 2 and increase the count by 1. Now again next element is 2, same as the candidate, both are equal, count is increment by 1, now count is 2. Now next is the 1 different from the candidate, so we decrease the count, now count is 1. Now next is the 1 again different from the candidate, so decrease the count and it becomes 0. Now count is 0, so we reset there, means next is the 1, candidate is the 1, reassign because count is 0, and now count is 1 here. Again count element is 2, both are different from the candidate, and count is the 1 here, 0 here, decrement it. So now in last element is 2, candidate is this again 2, and count is the 1 here, means we increment the count, and the array the final candidate is 2, which is our answer. So even though the candidate change in between, the majority element always survive. So let's move to the LeetCode and write the code step by step for this. So here first I create two variables, candidate and count. Let candidate equal to null and let count equal to 0. and I loop through the array for let num of nums, a for of loop in the JavaScript. And if the count is 0, I pick the current number as the candidate. If count is 0, candidate equal to num. And now I check if the number is same as the candidate or not. If it is same, then increase the count, otherwise decrease the count. Means count plus equal num is triple equal to candidate, then increase the count, else decrease the count by 1. So after this loop, I simply return the candidate, return candidate, and that's it. Very small code but very powerful logic. So let's run this. Yes, it accepted both the test case. Let's submit the solution. Yes, all the test cases are passed, 53 test cases. And the time complexity is the bigger one because we will traverse the array only one time, this for loop. And the space complexity is the bigger one because we use only two variables, the candidate and count, no extra variable, array or map. So this is best and most expected interview solution. Now I will briefly show you two more approaches. Please understand this clearly. These approaches are shown only for learning and thinking. For interview and submission, Boyer-Mori is the enough. So first is the divide and conquer. This approach is more recursive and theoretical. The idea is simple. The majority element of the full array must be the majority element of either the left half or the right half. So we divide the array into two halves, find the majority in both, and then compare. So let's see the algorithm. If there is only one element, array size is 1, then return element, and else we have to divide the array into left and the right part, and recursively find majority in the both halves and count both in the current range, and return the one with the higher count in last. So this approach uses the recursion, and it works, but it is slower than the Boyer-Mori because it uses the extra space and it is harder to understand. So you do not need to master this for the interview. And next approach is the bit manipulation, and this is the most advanced and most difficult to understand. And so in this is the simple idea is like every number is made up of bits, you may know, and if a number appears more than the half the time, then for every bit position that bit must also appear more than the half the time. So we count bits and rebuild the number. So this approach is advanced and not commonly asked. So you can see it as a thinking exercise, not a required solution. So time complexity for this big of n is 32 is the constant, as this one is the taking bit manipulation, and space complexity is the bigger one. But this solution is rarely expected but very impressive if explained well. So to summarize this, Boyer-Mori is the solution you must remember, and divide and conquer helps with the recursion thinking, and bit manipulation is optional and advanced level. So thanks for watching this video. If you understand this Boyer-Mori clearly, you have already learned the most important part of this problem. Like the video, subscribe to JDCodebase. I will see you in the next problem.